Welcome to the crime scene environment. We've got the kitchen in here, we've got the dining room here, and we've got the tools for the investigation here. So the clipboard will tell us what to do. First we've got to find the flashlight, which will be here, and then we've got to place the markers to create a timeline of events. And we've got to take photos of marked areas using the camera, and we've got to collect all the evidence and put it in this box. Okay, so let's grab the markers. We're going to make a timeline here. So there's a smaller scratch there I see and a bigger scratch, so we'll start with the smaller one, we'll go bigger. Looks like there's some blood on the floor there, so we'll grab these two, put 3 there, and 4 is probably at the end of the dining room, so we'll grab the flashlight and go into the unknown. Push us out of the way, and the victim looks like it's been knifed into the wall and then shot, so we'll put the 4 down and come back to this later. So now we've got to take photos of marked areas. So you see the camera has a screen on here, and we'll take pictures of the areas. It will print out a picture for us, and it will play an animation of the event that's happened at this area. So as you can see, the victim's washing up there, and the killer enters, and they fall back scared, and they use the counter to get up, and they grab out a knife which caused the scratch there. And the killer watches as they try shuffle along to escape, and then gets a bit more angry and disappears using a particle system. Okay, now we get the picture out. See, that's a pretty good picture of what we got. Let's do 2. See, the victim has a knife there. He's going to try stab and misses and gets punched. Okay, and then we got this picture here. It's pretty good. Let's do 3, which is a bit lower, so we'll get a bit lower. Okay, and the victim seems to be on the floor, crawling to get up. The killer has a knife and stabs him in the shoulder as they try to get up. So we'll grab this picture, it looks about good. And then we'll do the last one. See what happened down there. Let's take the picture. See, the killer seems to be putting a hand up and stabbing them into the wall. Okay, that's the end of the photos. Let's take this one out. Let's move on to evidence. So let's get this evidence box that's fallen over. And we'll put it here. We'll get all the photos in here real quick. There we go. That's one step done. So the next step is to get, let's see, knife 1, knife 2, murder weapon, and left, right hand. Okay. So now we're going to have to pull the knife out to get the knife. Just going to drop the hand down. We'll get the other knife out. Pull it, and it falls. Okay, so we've got everything in there. It's a lot heavier now. So next we've got to get the murder weapon. We're not done yet. So it's going to be somewhere in here. So let's have a look. In here? Nope. In the fridge? Nope. Maybe in the drawers. That one's a bit open, maybe up there. So we can do this many ways, but we'll jump up onto this. Then we'll reach up here, and we'll grab the gun, and close that back up. And we'll put it in, and that's everything done. So we'll close that, close the lid, turn off the flashlight, and we go home with our evidence.
This is my asset creation process, taking the oven as an example. Firstly, I find references from the time period like this General Motors oven. Next, I use typical dimensions and input those into a cubic blender. I model the oven in as low detail as possible, then shade smooth, mark seams and UV unwrap the model, dedicating more pixels to areas that will have more detail. I then pack islands, join the parts and name the object and material for correct unity and porting. Onto high poly modelling, I add all the details I can see, using many modifiers like subdivision surface and boolean. After that, I apply them all, check the face orientation, rename it, and export it as FBX. In Substance Painter, I make the high poly mesh details onto the low poly mesh. This allows the mesh to have the details of the high poly model, but with the less intensive try count of the low poly model, making it quicker to render. I add many smart materials to the mesh and use masks and brushes to paint details. I use smart masks to add inaccuracies and dust on the texture. To create the decals on the oven, I use Pixlr, an image editor that lets me create the images and logos. I drag these on and scale them accordingly. I export the textures using a preset I created which exports the maps needed for Unity EURP. When importing, I create a material object and then drag the textures into a folder. I connect the textures correctly and change the smoothness value. The higher the smoothness, the more reflective. Afterward, I import the mesh, connect the material, and generate light map UVs for correct lighting on the model. Next, I add cubes around where the collision should be, and delete the mesh components, which makes the colliders invisible. Using these primitive colliders is far less intensive than using a concave mesh collider. I then add interaction using joints, rigid bodies, or scripts, and then the asset is complete. All of the 40 models I made underwent this long process which formed a detailed environment for the scene. To light my scene, I added a point light and used Unity's physically based filter and temperature light appearance option to mimic the light of an incandescent bulb. I selected all the stationary objects, ticked static, and set the light mode to mixed. Mixed lighting allows for static objects' lighting data to be generated at a very high detail, while non-static objects can still cast real-time shadows. I then added reflection and light probes, so objects can reflect and non-static objects can be lit using baked lighting data. To create the killer model, I used subdivided cubes around a human reference and retopologized it to have better edge flow for rigging and a lower try count. I then rigged the body and added inverse kinematics. To animate the model, I used keyframes on the bones and enabled inverse kinematics for actions like punching or walking and disabled it for basic arm rotation. I imported the FBX into Unity, created an animator controller, and added the animation file to the graphical state machine. Finally, I added an animator component to the mesh, allowing it to play. For the effect where the animations disappear, I used particle systems. On the killer, the emission is set to their mesh. The color is set to a gradient from white to black, and trails behind the particles stretch and can fully hide the mesh as it vanishes. These dark sprawling ribbons signify their hate and sins. I made the victim's particles start yellow and then deteriorate to redness after each animation. The increasing red shows the danger of their situation increasing as they lose more blood. The dripping tap symbolizes the unfinished business of the victim, and the floaty dust particles add character to the house, giving the impression that it's old and decrepit. To create the black and white shader seen in the animations, I used the shader graph and added nodes to get the scene position and color, then divided it into black and white. I then set the material to transparent. The black and white effect here drives home the point that you're witnessing past events unfurl. This is also period relevant, as color TV was first taking off during the 1960s, and the contrast between the two were in the mind of the general public at that time. To make the clipboard UI, I used a world space GUI canvas with text boxes that allows the UI to stay on the clipboard and not attached to the player's camera, preventing immersion from being broken. The exterior of the environment uses modular placed assets that I created based on American houses. This allows me to build as many houses as I need while not needing to create models for each. The level design of the scene drives the player's journey. The dining room is not to be entered first, shown by blocking it off with chairs in darkness, while the kitchen is brightly lit. Leading lines in the dining room point towards the knifed hands. For the rigid bodies, I set the masses of the objects to match that of their physical counterparts, which allows for a convincing representation of inertia from interactions between them. 3 types of joints I use in this scene are hinge joints, configurable joints, and fixed joints. Hinge joints allow a rigid body to rotate around a single axis. This is used in the oven, fridge, and more. Configurable joints allow you to limit rotation and position on any axis. By only letting the local Y location be free, I made the knives pull out of the hand smoothly and without error. Fixed joints stick 2 objects together. The break force property deletes the joint after enough force is applied, which I used on the oven. When you close the door, a fixed joint is created for a script. This keeps the door from falling back down, and the player has to pull with a bit of force to break it, giving the illusion it has a spring to keep it closed like in real life. Triggers are scripted using on-collision enter and exit methods, and they can check the tag on the object to decide whether it should trigger the event. The evidence box uses this, as when it detects a collision, it checks if the tag is kitchen, knife, right hand, etc., and ticks it on the clipboard UI. If it detects it exits the collider, it takes the tick off the clipboard list. For the player to grab objects, I use automatic grabs and snap grabs. Snap grabs use hand poses, which I manually created by using the hand pose editor. It spawns in a dummy hand where you can position the bones. I also made the finger move when the player hovers over and presses the B button on the flashlight to pair real-world finger movement to the tools. The flashlight functionality is done through an interact script, where I can activate separate methods when a button or trigger is pressed, which makes the flashlight toggle or camera take a picture. To program the methods for the interactables, I used Visual Studio. In the basic case of the flashlight, I used an if statement and a boolean to check if the flashlight is on already. If it is on already when the button is pressed, it disables the spotlight, changes the boolean to equal false, and uses get component on the front of the flashlight to swap the material from the bright white to the darkened off material. In conclusion, many hours and much effort into this project afforded a scene of a unique and creative environment that engages the player in the story of the murder. The carefully crafted 3D models and materials, created and imported to an industry standard, gave a gripping visual design. These models, paired with expert lighting techniques, gave rise to this amazing looking scene, playable in VR with high frames due to rigorous optimization at every step.